All right, so here it is. Let's go with 5.4 and 5.5. They're talking about really almost the same thing here. It's the special forms, and if you remember, do you guys remember these little special forms? Remember multiplying a plus b squared? Instead of doing all of FOIL, remember what we did? We just said, hey, you know what? We can square the first term, double the products, square the last term. Done. Over here, if it's a minus b squared, we square the first term, multiply with a negative. It's the negation of doubling the products, squaring. And then this one, remember this one, this was the easy one. This one was a plus b, a minus b, which means we didn't have to do all FOIL, we just did the first numbers, and then we did the last numbers, and that was it. So instead of FOIL, we did FOIL, right? Okay, so we're going backwards. We're going to go, we have to recognize this form, and we have to say, you know what, if I can see this form, I'm going to write the factored form like this. And they are pretty sneaky, the way they're written. You got to just sort of like, I'm going to check. So this one right again, if you see this kind of form, we're going to factor down into this point right here. And again, the reason why we have these forms is because they worked for us in Chapter 4. So now we're just going to use these forms to get us back to factoring in Chapter 5. Okay, the easiest one to see is this one right here. So it's a squared minus b squared. You have two perfect squares, and you only have a minus. And that would be the easiest one. It's going to factor down to this. Okay, word of caution, ready? And careful, careful, careful. Do we have to have a negative in the middle? The other answer. Yes. We're going to have a minus in between, because look at this. A times a is a squared. B times a negative b, remember, because they're always going to have opposite signs, right? So if you have a positive times a negative, you're going to have that negative there. Okay, so we're looking for this form that has perfect squares at the ends, minus in between. Plus, not going to work. In fact, there is no formula for plus. And so let's talk about that, because that tends to be a problem. If there was a plus formula, right, they would have to both be pluses right here, right? They would have to both be additions right here. And so if that is the case, let me just kind of do it real quick here, because this becomes a sticky point. So I'm going to change this to a plus right here. So if I do that, it's going to be a times a times b. So notice the middles are not canceling anymore. Everybody good there? And so there's no way I can get an a squared plus b squared because of the cancellation process. In fact, hold on, isn't this one just really this one right here? A plus b squared gives you this. The middle's double. If it was a minus b, the middle's doubled. But if you have one is positive, one's negative, then the middles will cancel, and you have to have that minus there. Cool? Again, important, comes up later, and that's the mistake that students make with factoring quite a bit with that. Okay, now let's go for it. All right, here's what we got to do. I made the formula next to the number itself here. Just some practice problems here, and then we'll go into what we need to go into. Just want to show you maybe an example, one of each type, just so that we see it, because then it becomes so fast here. Okay, so this one right here, factor x squared plus 6x plus 9, and these are the very easy ones to factor. I want you just to sort of recognize the form over here. Where's the form on this? So, what we notice about the form, first of all, is you have perfect squares at the ends. In fact, look at this. Don't you always have perfect squares in all these forms? They require perfect squares at the end. So, is x squared a perfect square? Absolutely. Is that 9 at the end a perfect square? Yeah, of 3. So now the question is, does it match up with the middle? Notice what the middle says. I got to multiply that a into here. Got to multiply the b into there and double it. So now the question is, if you multiply the x and the 3 together and you double it, will you get the middle? Yeah, and if if you got the middle, then there's your factored form. It met the criteria and is just a plus b, in this case x plus 3. Okay, good there? Next one. How about this form here, where you have a squared minus 2ab plus b squared. Alright, what gives it away a little bit here is this little minus sign right here. Okay, so again, the question is, do you have perfect squares at the end? I think so. Isn't that perfect square of 5x? Is 36 a perfect square? Of 6, so there's my perfect squares at the ends. And now the question is, if I multiply them together and double them, would they give me the middle? Yes, they would, with this extra little caveat of this little negative right here, right? So it's technically a multiplication by -2. Alright, if it fits the form, then it's 5x minus 6y squared. Right, and the easy one. This one's going to be pretty easy here. Perfect squares at the ends, yes. 4x and a 5. And the only other question is, do I have a minus in between? And if I do, then the answer is 4x plus 5, 4x minus 5. Okay, just wanted you guys to see all three forms before we get started. Again, we're taking this form, using that as the factored form, so as long as these two fit together. So 5x is what multiplies to give you a 25x squared. Because we have this.
I get the 5x
okay.
minus 2, 30x, 6, but then down, and you drop it.
So this is your a value. The sign, notice the signs stay the same. Sign, sign. So sign, sign, and then this is the b value, because that's what was squared to give you the last term. Alright, now let's go for it here. So I'm going to intermix these forms a little bit together, and we already talked about that. So start off with the easy ones, then we'll work our way up to more interesting ones. Alright, two terms. Two terms should sort of give it away already. I have two terms here. Perfect. 5x plus 4, 5x minus 4. This is where you ask, Mr. H, can we just have like 50 of these kind of problems on the test? No. Because I'm mean. Alright, 49x squared minus 1. So 7x is good. Okay, and then we should realize 1 is a perfect everything. 1 is a perfect square, 1 is a perfect cube, 1 is a perfect fourth power. It works all the time. So 1 squared to give us 1. Alright, so how about 7x plus 1, 7x minus 1? Alright, and slightly tricky one here. Let's go with this one here next. It's x to the 4th. So what squares to give you x to the 4th? Hey, x squared, huh? X squared squared, or x squared taken to the 2nd power. Cool. All right, let you guys finish that one. All right, x squared there, a 4 there, and everybody okay with x squared plus 4 and an x squared minus 4? Karina? It's this form right here. And again, we're just matching up forms, that's all. So as long as we can match up to this form right here, we get ourselves this factored form. So as long as we can match up something being squared, another something being squared, and we got a minus in between. If we can match it up, we're good.
How are we gonna know that you want it in that?
Oh yeah, that's what I was gonna ask.
Like, will you put, like, is there a certain title for that, or how do we not know that you want it in the second form or the third?
The question is, and let me see, rephrase it just to make sure I understand. How do I know that I want it into this form, right? Is that that's what you're saying? We are not,
There's only two variables?
yeah, we're not picking a form. We are seeing if the form matches. So we're saying, okay, does it fit this form? If it does, then from chapter 4, we know this is the factored form. Because we did in chapter 4. That makes sense. Okay, real quick here with this one. If it matched the form, yes. Perfect square here, yes. Perfect square here, yes. Minus in between, yes. This factors in 2. Whatever was squared to give you x to the 4th, whatever squares to give you the 16. And again with the minus sign. Now, the interesting question is, are we done? Karina?
What if it was like x to the 6?
Ah, perfect. Let's do that. Let's say x to the 6 minus 16. So anybody, can you tell me?
S cubed.
X to the 3rd. Yep, that would do it.
Um,
And this would be 4. And here we go. X cubed plus 4, x cubed minus 4. Good question. Yep, you got. If you have those questions, please ask right now, as opposed to throwing the book across the room because you don't understand. Okay, the trivia question is, are we done yet? Okay, the people that are shaking their heads no. What else can be factored?
The S. S
Or set X.
and
Which one? This one and this one? Or just the second one, just the first one? What?
both, but
Both? Let's see. Does it fit this form? The first one doesn't fit the form, right? And again, we talked about this here. If we are going to cancel off the middles, one has to be negative, one's positive, and if we multiply them together, you're going to have a negative in the middle, right? So the only form you can have is this form. So this one meets that form, doesn't it? Absolutely. Okay. Go for it. What is that going to be? X plus 2, x minus 2. I like that. Okay, so the first one stays exactly the same, no change. X squared plus 4 does not do anything. This one now. Yep, x plus 2, x minus 2, and we got ourselves finally. That is completely factored. Okay, are we good there? Any questions on that? Again.
The x squared plus 4 has to go at the
Good question, and that's something we can talk about here. Whenever this form breaks down, the formula for it is a plus b, a minus b. That's the normal way we write it. And remember, we talked about earlier, it doesn't really matter which order this comes in. So yeah, you can write it as a minus b, a plus b. That's fine to write it like this as well, no problem. The reason why this is the preferred method right here is because of this situation right here. Because once you do this here, this one for sure will not factor down anymore. This one can still factor down. So it's sort of like you're leaving the first one the same, and then you can kind of just check the last one. Because if you write plus in there, then you know you're done with that one.
what if it's like a 5 and you can't?
Go for it. Let's go. These are the questions. You got it. Tell me. Okay, real quick here. Do we have perfect squares?
I mean, like instead of the 4, it's a 5. You can't reduce that anymore.
Ah, good. The question is, if this guy became a 5 here, if this was a 5, this was a 5, you're right. This would stay just like that. No, yep. It's because that 4 was still a perfect square. Cool. But I still want to get to this one here too. How about this guy? Can that be factored? What squares to give you x to the fifth? We already talked about x cubed here. This would be 6, right? Because remember you have to multiply the exponents.
None.
Okay, none. So this guy does not factor. There's two different ways to write. You can just write cannot factor. Some textbooks, what they have you just write down the same exact terms, basically just saying that it didn't go down. All right, and the other one is to say it's something called prime. Cool. And just saying that means that does not break down anymore. So there's kind of three different. We'll run into those sometime. Any question, Kelly?
I still don't get why the a squared minus b squared goes only to the second.
Why this breaks down some more? Is that the question? Why the second part still can break down some more? Okay.
But not like the
First one, you got it. Okay. Let's do this here. Let's go back in our minds to chapter 4. We're good? Just real quick here. Chapter 4. And we say x, and again, I'm going to use different numbers here. X minus 3, x plus 3. If I look at this number here, I'm going to do FOIL. Boom, this is x squared. This is 3x. This is minus 3x. And this is a minus 9. What happens in the middles? They canceled. Okay, the only way to cancel the middles is if you had opposite signs. Good there? But if you have opposite signs and you're multiplying these guys together, you're always, always, always going to have a minus right here. If you're going to have a minus here, so again, in chapter 5, we're going backwards. We're going to say, okay, I'm going to recognize this form. I want to be able to recognize this form and then go back to this. Now, you cannot cancel the middles. The middles will not cancel if both of them are positive. And in fact, let's do that one right here. So x plus 2x plus 2. If I did that, this would be x squared. 2x. You get another 2x, and then you get a 4. So then those two, no more canceling, right? So then you get x squared plus 4x plus 4, which is not this right here. Okay, does that make sense? So in order for the middles to cancel, for only us to have two terms here, it would have to be one's a positive, one's a negative. And then when you multiply them, you'll always have a negative in the middle. Okay, see if that sinks in. Are we good? All right, no problem. That's what we're here. All right, ooh, gonna change forms on you. Okay, can you recognize the form? Yes, great.
Are we gonna have to know the forms for the test?
Mm-hmm.
The second form?
All three forms, right? You probably have to know all three. Ah, yes. Uh-huh. Yeah. 3x5 cards come so in handy. Is that right? Sorry. Okay. Number 4. Let's go for it. Hopefully recognize the form. In fact, we can even say, is this the first form, second form, or third form? So let's go back. Go back to here. So here it is. Here's my first form, second form, third form. Which one is it? Second form, yeah, because it has a little minus in between right here. Trinomial, perfect squares, minus in middle. So boom, perfect square of 2x, perfect square of 3y. Now the only thing is we've got to check the middles here. If you multiply the ends together and then you double them, will you get the middle term? Yeah, with a little minus there. So again, fit form number 2, therefore 2x minus 3y is the factored form. And again, we learned these from chapter 4 because we did a whole bunch of them and said, hey, you know what? Okay, adding an extra little step here. Let's see, the extra step is, I'll give a hint here, something called greatest common factor. Oh yeah, let me go back real quick here. All right, number 5 here. Let's go with it. The hint is greatest common factor. Greatest common factor. Can you take out the greatest common factor first?
3.
Cool by me. All yours. All right, 3 goes out. Leftovers will be x squared. Let's see, plus 8x plus 16. Is that right?
4.
Awesome. Okay. This one, if you should recognize the form, there's x, right? 4 at the end. If you double those, multiply those and double those, do you get the middle? Yep. So this is first form, second form, third form.
They're second now. First one.
First form. First form is the trinomial with all pluses.
Oh, I
So-
mean,
All right, let me just go back. Roll. Sorry. All right, real quick here. I can go back to this one here. There it is, right? First form, all
they're so
pluses.
similar, it's just,
The minus sign, plus sign. Yep. So answer is 3, and then we have x plus 4 taken to the second power. Okay, now a quick little word before we go on. This one, do you have to check the form? Could you have also done it just as x squared is x times x? Two numbers multiply is 16, add to 8, or how about this? 16, 8, 4 and 4, yeah, blah, blah, blah. Done, and then we write it like this because they have the same factor. Okay, how many did it that way? Raise your hands. Cheaters. No, just kidding. Yeah, you could do it the second one because this is such an easy problem. Okay, the one that we really use the forms on would be number 4. Now that one, again, a lot more difficulty here, right? Those are the ones that you probably wanted, like, what? I'm going to check if the form fits. That's when we do those. Okay. Okay, and jumping to the weird one. It has a binomial as a perfect square. That's no fun. All right, the weird one here. Which form is it? First, second, or third? Hey, third form, is that right? It's this guy right here. What is being squared to give you x minus 4 squared? X minus 4. That's what it says. Okay, what's being squared to give you 36?
6.
6. Cool, so let's write it in here. Let's see. The factored form of this guy is the first number plus the second number, and then times first number subtract second number. In this case, our a value is x minus 4. We're good? So,
Could you reduce that even more?
Yeah.
And
so x minus 4, the first number plus the second number. First number plus the second, I'm sorry, minus the second number, and then yes, Karina's right. Simplify as much as you can. What do you guys say?
X plus 2.
Not minus 2. X minus 10, you got it as negative 4, subtract 6. Alright, why is factoring so important? Is because we live not in a one-dimensional world, we live in a three-dimensional world. So anything that has any curve to it, again, we're going to have x squareds in it. And because of that, we have to be able to go from x squared. So notice this thing has a 2 inside it. Notice at the end, aren't these just linear functions now? Doesn't this look like mx plus b? This is mx plus b. So factoring allows us to go from x squareds down to a linear form. And now we can work all that stuff with linear forms. So then? Sure. Question is how to get a negative 10 is this guy right here. I've got the x together, negative 4 subtract 6. If you don't want to subtract, you can always add the opposite. And you get yourself a negative 10. All right, good, good. All right, that was 5.4. Jumping to 5.5. Now this one, these two forms we actually did not have in chapter 4. They just sort of give it to you. Okay, these are two more forms. We got to deal with them because they're used quite often in factoring. And so those are giving me the sum and the difference of two cubes. And now if we think about it, we have 5 different forms, is that right? To deal with here. Alright, but before I give you the forms here, well, maybe I did give you the forms. No. Let's do one little example here. X plus 4. Let's multiply it with x squared minus 4x plus 16. And again, the reason why I chose it, from my own brain, because we'll sort of see something. Okay, this is just the example from me. All right, and let's multiply this out just like we normally, because it's the multiplication. This is a type of chapter 4 problem here. So x times x squared, x cubed, cool. X times the negative 4x, negative 4x squared. X times 16, cool. Okay, got it. My x has multiplied everything. Then let's multiply by 4. 4 times x squared. And then what I'm going to do, I'm going to write it underneath the like terms here. Notice I'm going to get that. 4 times a negative 4x. Cool. And then 4 times 16. 64. Okay. And let's add this guy up. What happens? Notice the two middle terms now, not just the single. The two middle terms cancel. That one and that one, we bring down that 64. So now we're dealing with not squares, we're dealing with cubes now. Okay, so, 1 second. Thank you. No, didn't want to do it again, okay. So here's your two forms. One is the addition, it'd be like x cubed plus 64, then there's also a subtraction. So for cubes, you can actually have a sum of cubes. You can have a difference of cubes. You can have both. Alright, so again, we're just recognizing the form and using this equation. So what I did here is the forwards, or this is the chapter 4 way. I showed that if I multiply something looks like this, I cancel off the middles. Our job is to go backwards. Our job is to go from here back to here. So we should recognize, hey, once I see a little 3 right here, I'm going to ask myself, you know what? That's being cubed. So now, is this number also being cubed? Yeah, because 64 is 4 cubed, right? It's also a perfect square, huh? Isn't that kind of funny? 64 is a perfect square of 8. It's also a perfect cube of 4. Alright, once we got that, then we're going to try to get back to this form right here. We want to be able to write this out like that. So, in this form, again, if you have a 3x5 card or something else to write it down with, sort of practice writing it down, all that good stuff here. But we're going to go from this form to this form again, from difference of 2 cubes down to this form here. Okay, but let's take a look. Let's take a little bit of time just to sort of let me do this here. Let's take a little bit of time to look at the forms. It's pretty easy once you see this sort of like the little patterns here. It's almost like easy to memorize it here. So let's take a look at it here. So if you have a cubed plus b cubed, if you have two things that are being cubed, plus sign, notice the first parenthesis is the same exact thing except for nothing's cubed, everything's linear now, right? So that's kind of easy to see. So this goes to this without the cubes. Then, in my mind, what makes sense is you have to have an a squared here, because when you multiply these guys together, you got to have that a cubed in the beginning. Minus sign comes in because you have to cancel off the middle terms, right? So the only way to cancel it, this is plus, then this has to be a minus. All right, the only weird part is the multiplication of this two. So notice there's not 2 in here. It's just a times b. And then at the end, in order to get b cubed, well, a positive b has to multiply a positive b squared to get you b cubed. That works the same way. So once you sort of look at it for a little while, like, oh, that makes sense. Let's take a look at the bottom. Difference of 2 cubes. Well, notice the same stuff is written except for cubed. It's a linear fashion. Again, you have to have the a squared to give you a cubed. Opposite sign to cancel the middles. Multiply them both together. And then put a plus b, because you already have a negative b here. A negative b times a positive b squared gets you that negative b cubed at the end. We're good. So again, just staring at it for a little while, you can sort of see the patterns here in a few spots. All right, let's go for it. Let's see if we can factor a difference or the sum of 2 cubes here. All right, so the 3 should give it away. You should see a 3 and say, oh, got it. It's a 3. So instead of thinking what squares to something, you can say what's cubed to give you x cubed. X, of course. What has to be cubed to give you 27?
9.
3, right? 3 times 3 is 9, times another 3 gives you the 27, so 3. All right. If you recognize the form, and if you can do the form straight out of, at this point, go for it, right? Because it's going to be a plus 3, right? Go from there. Most Math 61 students, it also helps to just to do this, because the formula is based upon A's and B's, right? So if you can just label all this, and so the A is the X, right? The B is the 3. So how about if you square the A? What's going to happen here? X squared. Square the b gives you 9. And what happens if you multiply the a and the b together?
9x squared? No.
Just the a and the b, not just 3x.
Oh.
Okay, once you do this here, then you have all the stuff you need to finish off the problem. Then at this point you just follow the pattern. The pattern, I'll give it to you over here, is a minus b, a squared plus ab plus b squared. So then just follow the pattern as you finish it off. Alright, so again, a minus b, so x minus 3, parentheses, parentheses, a squared, opposite sign, a times b, which is 3x, plus the b that's being squared, so 9. Okay, good there. 2, all yours if you got it. Alright, let me begin as well here. I think most of you guys are almost done here. So the 3 gives it away again. What's cubed to give you y cubed? Y. What cubes to give you 8? 2. Again, following the other form this time. A is equal to y, b is equal to 2. If you square the a, gets you y squared. Square the b gets you a 4. Multiply those guys together. How about a 2y? And again, you're following the form. This time the form has slightly changed. It's the a plus b form. Again, a squared, opposite sign. A plus b squared. So it's this form here. So as we do it, just follow the pattern here. So we got ourselves y plus 2, y squared minus 2y plus 4, done. Good there? And of course we're going to get more sophisticated. That was just to start us off. Got a few people still writing it out, so go for it. Alright, moving on. The more sophisticated ones here, so let's go for it. Real quick here before we go on, is there anything sort of wrong with number 4? Is there?
The X and the Y.
I'm just wondering here because I have it's highlighted, so I know there's something wrong. Is that what? Just real quick here, is that what your match problem says?
I think the problem might be the answer. Sometimes the answers don't match up.
Yeah, I think it's the answer sometimes didn't match up or something with number 4 on the match problem. I think that's what it was. Okay, but anyways, let's go 3 and 4. I'll give you the right answer, so let's go for it. If you want to try it yourself, maybe a minute, try it yourself, see if you can get both of those. Alright, those are waiting for me. Let's go for it here. So look at this one. The y gives it away again because it's y to the 3rd. So now it's just kind of reversed. The variable's on the back side. That's okay. What cubes to give you 8? 2. What cubes to give you 27y cubed?
3.
3y. Perfect. So if you want to label these guys, how about a is the 2? B is going to be our 3y. Okay, so if you square the a, gives you a 4. Kind of careful here. Square the b would give you 9y squared. Everybody good there? And then multiply the original a and the b together. What do you guys say there? 6y is good by me. Okay, again, following the form, hopefully you have it in front of you if you have not memorized it yet. But it is going to be a plus b, close parenthesis, open up another one, a squared, which is 4, opposite sign, just a and the b multiplied together, plus sign always, and then the b squared, which is 9y squared, close off parenthesis. Ah, cool. The question is, can I sort of move these around? You can, yeah. You can put the 3y plus 2 first, and then eventually, yes. I think you're probably going to have to get it to this form first, then scoot it around. But you don't have to scoot them around either. Cynthia, question? No? Okay. All right, and number 4. Let's go for it. What is being cubed here? I think I heard it somewhere here. 4, right? 4 times 4 times 4 is 64. And with an x. All right, what is being cubed here? 5 with something else. Yeah, 5y, right? Don't forget the variable in there, as you're going to be. So a is 4x, b is 5y, and let you guys finish it off. All right, so a squared is going to give you a 16x squared. How about a b squared gives you 25y squared? And then the multiplication of those two, how about a 20xy? Everybody good there, at least with the items there, and then just follow the formula. All right, any questions on number 4? Okay. All right, next, of course, is fractions. Got to deal with those. And let's see, and let's do number 6 together. So, if you want to take a try at number 5 by yourself, maybe I'll give you guys like 30-second head start here. How about that? But then wait for me to do number 6. Let's go for it. So, how about a is equal to a? Is that right? B is equal to a 1/3. If you do it by terms here, so square the a, of course the same thing. If you square the b, it gives you 1/9. Is that right? It's 1/3 times a third. And the multiplication of those guys together would give you 1/3 times a, or you could put a over 3. Either one of those would work. All right, and the factor form a minus 1/3. How about a squared plus 1/3 a, or a over 3, plus 1/9. And there's your final form. Ooh, and of course I do have to ask this. Raise your hand if you got it right before I show the answer. 1, 2, 3, 4, 5. Okay, you're almost there.
Yeah.
So you can count to like half, like 4 and a half.
Like this part from when I said it.
Okay, number 6 is a little different. Notice you got a 6 on there. And so let's go with just a little bit here. Just want to show you a few things here. So 6. 6 is a fun one here. Now, don't write this down yet. Just kind of think with me for a little bit here. The 6th power. Can you guys talk to me? Not this one. I don't want this one first. I want this one first. Okay. What cubes to give you x to the 6th? Yeah. No. 2, right? X squared, because you multiply the 2 and 3 together, right? But hold on. At the same time, could that also be a perfect square? Yeah, what squares to give you x to the 6th? 3, huh? Because 3 times 2 would give you 6. So we have a section. We can either go with the cubes, we can go with the squares. Kind of depends which way you want to go. All right, if you have a choice between going any one of those ways, in order for factoring to work out all the way through, you have to go with the perfect square first. Then you go to the perfect cube. So that is always... So yes, there's an order in these guys here. So we're going to go with perfect square. So a little bit of a long one here, so let's go for it here. Let's see, x cubed, is that right? So we're looking at 64, and we're thinking of a perfect square instead of a perfect cube. 8, right? 8 times 8 is 64. Okay, so then can you give me the difference of 2 squares? Form number 3.
X minus 3.
Okay, x cubed minus 8, or plus 8, right? And x cubed minus 8. Are we good there?
So that's the answer?
Now the question is, can this be broken down any more?
Yeah.
Yeah, in fact, each of those can be break down, right?
Yeah.
Ooh, so you guys have fun. Can you break down x cubed plus 8, which does break down? And then can you break down x cubed minus 8, which also breaks down? Hopefully you finish this up here. So breaking down a x cubed plus 8, again, x is being cubed, the 2 is being cubed here. Following the formula, you should get x plus 2. Square the x, opposite sign, multiply those guys together, plus square the 2. Good there? And again, eventually, hopefully, you sort of move away from, you know, labeling the a and the b. So you can sort of do it in your head here. But the second part here, what's being cubed is x, what's being cubed is 2. This one has a minus in between, so let's go with x the original minus in between with the 2. And then we square the x term, opposite sign to cancel the middles, multiply the terms together. 2 times x, plus always at the end, and square the 2, close it off.
That's the answer?
And that is the complete final answer. Question?
How come we didn't do that straight after getting x cubed?
Because we were, the question is, why didn't we do this after getting the first form? It's because we were working on factoring down this initially. We saw it to be a difference of 2 squares, so then we had to finish off that factored form, and then we check to see if we need to factor some more. Okay, we're good there. A few people are just finishing up here. Go for it. Okay. Whew. All right, we finally finished all the different pieces now. Now we have the finally putting everything together. And I should print this. I should sort of like maybe type this up. This is my little invention, because the way the book presents it on page 329, all of it's in English, and there's no formulas there, and it doesn't make sense, and it says follow this checklist, it will help you. And I'm thinking, no, it won't. And so I made up my own little diagram here of the way we should sort of be thinking about it. I don't know, what do you want to do? Take a picture of it if you like. Writing it down, maybe I'll give you like maybe 2 minutes or so if you can write it down. So I can take a So 5.6 is finally, we've been looking at pieces all throughout 5.1 to 5.5. Finally, we're going to put it all together. So how does the puzzle look? What do we do? Is this right here. So first step, in factoring there's only 2 steps. The book says 5. I don't think so. Just 2. First step you always have to do, if you can, you have to see if you can factor out a greatest common factor. First step, we practiced it, that was the first thing we did, right? You always check, and it's if possible, because it may not be possible, as many times it wasn't. Step 2, then all depends on how many terms you have. That's it. So if you have 2 terms, if there's 2 terms, notice what I put in here. It has to be a special form. There's no other way around it. So it's either, and we kind of go in this order. Remember that if we see cubes or squares, we've got to do squares first, right? So if we see a difference of 2 squares, we've got to factor that one down. If we see a difference of sum of 2 cubes, we factor that one down. Difference of 2 cubes, we factor that one down. So all it is about 2 terms. If we don't have 2 terms, we go down to here. Then we move on to 3 terms. And this one, it may be a special form. And remember the 2 special forms we have? We just worked on them right there. Now this one, it says guess and check. Maybe we can write this in or. Let's just put this or X box. Let's do that here, so at that point it's either a guess and check method, or we're doing that little X box sort of method. Cool. So we check first if it's a special form. If it isn't, then that's what we have left. All right, C is if you have 4 or more terms. If you have 4 or more terms, then we have to rely on the grouping method to make sense of that. Okay, we good? Nothing new here. You guys have been factoring all this time, okay? So there's nothing scary gonna jump out, okay? Let's just follow the process here, and let's go maybe 2 minutes each or less than a minute each here. Let's go for it. Factor 4x cubed minus 36x. Step 1. Is there a greatest common factor? Can you factor it out? Ooh, good. 4x, right? We need the 4. We also need the x. And remember I said if you don't factor everything out, it's going to be messed up the rest of the time. Cool. What's left over?
X squared.
Uh-huh. That's good. X squared. Yep. The minus sign comes down because we didn't do that. And then what multiplies 4x to give you?
9.
Thank you. 36. It's just a 9. Okay. Next question. Does that factor down anymore?
Yes.
Yeah. That's a difference of 2 squares. So remember, step 1 is done. We took out the greatest common factor. Look at step 2, 2 terms, and give me x plus 3x minus 3. Go there. And again, you have to just do a little bit of stuff in here, and you sort of, it makes sense after a while to get it. Okay, good. Number 1 done. Next. All right, again, I'm gonna remind you, step 1. Alright, step 1 done. Hopefully you guys factored out at a 2x squared. If you just did 2x, you need to get that square against the lowest exponent, which is this one. You got to factor it out. X squared is left over, and anything else?
10x.
10. Uh-huh.
Plus 25.
Perfect. Okay, here.
X plus 5.
Perfect. Okay, so this one kind of depends which way you went. If you, this was an easy one, so 2 numbers multiplied to 25 add to 10, 5 and 5. So x plus 5, x plus 5. Or if you recognize this to be that special form, notice x squared, this is the square of 5. If you multiply the x and the 5 together, get 5x, and you double it, gets 10. This one wouldn't matter that much. Okay, so this is the correct answer. This is also correct answer. Both of them would be correct answers. It would not matter. All right, next, the tricky one. I'm going to remind you here, step 1. Can you factor something common? I'll go with that, yeah, A. Is it A is both of them? A to the 1 factors out, leftovers.
16.
Plus 16, okay. Alright, can you factor down some more?
8 plus 4.
No.
Good, I don't know.
No.
I was too fast to say good, huh? Alright, this one does not factor down. How come this does not factor down? Because remember, for 2 terms to exist, it has to meet a special form. Does this meet any of the special forms? No, it's not a difference of 2 squares, right? Because the only way you can get the middles to cancel is if you had opposite signs, right? So if it was a squared minus 16, yes, it would factor down some more. So this is it right here. Notice what we did is, though, we were able to do 1 step of factoring. If you can do 1 step of the factoring process, you still have factored it down. We good? If you say cannot be factored, that means you can't do anything with it. You can't do step 1, you can't do step 2. Okay, number 4. All right, first, step 1, were you able to factor out a greatest common factor? Ah, no, not this one. Okay. All right, and then guess what happens here? 8x squared. Hey, there's a number in front of x squared, so I got some possibilities here, right? Hey, that would not work, right? Let me try with this here.
Can you refactor this one?
I don't know. So I'm going to try here. And so two possibilities. Let me write it another way here. So you could have a 8x times x. That's one possibility for the front numbers. You can have a 4x times 2x, right? That's our possibilities. Oh, cool. Okay. So 9, it could either be a 3 times 3, or a different possibility is 9 and 1. But eventually, I want to get myself a 6 in there somewhere.
3 times 3? Yeah.
3 times 3? That's the one with you? No, can't do it because of that. Because once you plug in, let me show you that real quickly here. Because once you plug in a 3 and negative 3 into here, right, because it has to be a negative 9, you got this little 8. That's the problem. You got this 8 that's going to multiply these guys together. So you got to do this. Does that add up to a negative 6x? No, because that little 8 in front now messes everything up. You can't just look at the 9 and the 6. Alright, so that didn't work. Let me just kind of try it again here. The 3's did not work, so I'm going to choose a 9 and a 1. And again, I don't know which way the signs are going to go, so I'm just going to put one's a positive, one's a negative. I know I have to get a negative 9 in here. So let's see if this works. Negative 8x. This is 9x, and that's a 1x. Is that right? Not going to go. Alright, do it again. Oh boy. This time I'm going to put the negative 1 here, and I'm going to put the positive 9 here, because I got to switch the numbers around now. So yeah, that's what it's called, guessing and checking. Okay. Boom. 72x. Oh boy, never mind. Not even going to look at that one. I know that's going to give me negative 6. Okay, jump back over here. 4x and 2x. Do the same thing here. Positive 3 here, minus 3 here. Let's see if I get a negative 6 out of this. Dink. Negative 12x. 6. Hey, I got it. I think that's it, right?
Yeah.
Ding, ding, and I got myself to negative 6. Okay. I want to show you a little something here before we leave number 4. What happens if my signs were off? That's what I want to show you. If my signs were off, if I put a minus 3 over here and I put a positive 3 here, notice what's going to happen here. I multiply the outer terms, gets me a positive 12x this time. I multiply the inner terms, giving negative 6 this time. And what's my answer? I get myself a positive 6x now, which is the exact opposite of what I want here. We good? So if I did this, I said, oh, I got it except for the sign problem. So in this case, what you can do directly from here, you can just switch the signs and you are correct. So if it's the sign problem, that we just switch the signs over to the other side, and done. Okay, the guess and check method here. Okay. Next one, all yours. All right, this one, number 1, we're able to take out a greatest common factor,
Yes.
which was 5x is good. Yep. All right, finally easy one here. Whew. Okay, that's the easy one because then it's just 2 numbers.
5 and x minus 2.
Awesome. Love it when they're easy. Okay, it's number 6. Sorry, do I need to go back here? Number 5?
Yeah.
Sorry. Cool. All right, let's jump to number 6. And again, something about greatest common factor.
3.
3, with some variables in there as well.
S squared,
Mhm.
Y cubed, Y squared.
Y squared, okay. Cool. All right, let's go for it here. So 3x squared y squared should be the number on the outside. Leftovers are given, and they look like this. Okay, so there's a little bit of an issue here. So first things first. Notice the middle term is just x squared by itself. Notice the last term is just y squared by itself. I think we've seen something like this before. Let me go back all the way to 5.1 when we were graphing, when we was factoring this stuff. Again, I'm going to just choose something from my mind, okay? Something like this: x squared plus 3xy plus, let's say, remember factoring something like this? You guys remember? Notice on the x's, it's x squared, then the x, and there's no x whatsoever, right? Then there's no x's, no y's, sorry. Then there's a y to the 1, then there's a y to the 2. This guy is called factorable in form because the variables make sense. X is going down by 1, y's are going up by 1. Is that the same thing that's happening here? So let's go and put the one that has just the x by itself, or the x squared by itself. It goes like this. The one that has both of them in there. And then the one that has the y squared by itself. So we're just trying to arrange them so it looks like this. And it's not quite the same, because see this little x squared over here? That's also there. If the x squared wasn't there, then it would still be factorable in form, right? The x's have to go down by 1, the y's have to go up by 1. So not there. Okay, so at this point we're done. In fact, this one or this one, it doesn't matter. This one would be correct answers. Okay, the last two problems here. Alright, let me start it here. So number 1, is there a greatest common factor? No. Okay, number 2, not 2 terms, not 3 terms, 4 terms. Cool. Something called grouping method. You got it. AX minus 2A in the first term. Remember, grouping method always has a plus between the 2 parentheses. Always works that way. Yep, perfect. Okay, and then we go from there. And some of you guys are done, so that's a good thing here. So I'm going to factor out the A. X minus 2 leftovers. Yep. Next one. B factors out. Leftovers. Awesome. And then we say this is a term, this is a term. What's common to both is the x minus 2's. So now we factor out the x minus 2's. And A plus B is the leftovers, or are the leftovers. Kelly.
So say in the middle there's a subtraction sign.
Mm-hmm.
Would it still be plus?
Cool, yeah, let's take a look at that here. question is, what happens if in the middle there was a subtraction sign? Well, how do we handle that? So let me set up a problem. Minus, this is my minus bx minus 2b. In fact, to do it, I'm going to put a plus sign right here. Okay, in this case, what we're going to do, we're going to go like this, plus sign here. We're going to take the ax plus 2b right there. Those are 2a. And then we think about that as a negative. Negative bx minus 2b. And let's finish it off here real quick here. Factor out the a here. Leftovers would be x plus 2. Here, what would we factor out? Yeah, we would factor out a negative b this time, right? Because you want to factor out this guy. And leftovers, hey, what do you know? X plus 2. So then in that case, the x plus 2's go out. And then final answer, a minus b. Good question there. Kelly, we didn't have one of those on the match problems, but good question. Okay, does that make sense? Karina?
Say that one of the twos had like a plus and the other one was a negative. Would those cancel out? Would just leave you with a. Do you know what I mean?
Yeah, let's see. You mean if this one has a plus 2a, this was a minus 2b?
No, these over here.
Okay, this one has an x
Yeah.
plus 2, this one was an x minus 2.
Mm-hmm.
Then you could not do this using the grouping method, because these two parentheses have to be exactly the same in order to work, because you have to factor out the exact same term. All right, and last problem. All right, and look at this one here again. Nothing to factor out of all four terms. So number one's gone. There's no greatest common factor. And I see four terms again. So again, we go to grouping method here. So first two terms, the last two terms, 3b. Awesome. So a plus 2y. Then just a y goes out of the second one. So a plus 2y again. Perfect. So then factoring out the a plus 2y, leftovers would be 3b plus y. All right, and that is the end of 5.6.